JUnit is a very Java-centric testing framework, but it has mimickers all over. There's NUnit for .NET testing and many other tools that do this in other languages. But we're gonna really kind of dive into the high level of what JUnit does as far as automation goes. We're gonna see that. You've probably seen it already in the class with a lot of the assignments that have been out there. But we want to talk about the value add that is JUnit. I mean, fundamentally, JUnit's goal is to support your testing plans. JUnit does not tell you what to test, doesn't tell you how to test it. It just gives you a language and a tool set, and I say language, it's Java, but it gives you the methods that help support the testing concepts, that takes whatever you want to test and then makes it repeatable and makes it automatic, so you don't have to sit there and click everything every time and type things in every single time. So it automates the execution. It gives you a very, familiar structure for reporting, and then some common interfaces, both for the computer and the user standpoint, for reporting those things out. And it's not just, in Eclipse. JUnit testing is used for what's called continuous integration systems, where every time somebody changes a line of code and checks it in, the system goes through and it can rerun all the tests and tell you whether that changed code has broken any of the tests and whether it should be rejected or be able to move on. So the idea behind JUnit tests is much like the idea of any software design. JUnit organizes its unit tests within classes, so each class tests something. Now, again, a JUnit class might test one other class. It might test part of a class. It might test 5 other classes. It might test a whole interface. There's no specific hard and fast rule for, one JUnit does one of something else. It's up to you for your design. But typically, a JUnit will do a component, which could be a class or a couple classes. You can have some number of test methods in that class. You can have 1 or 100 of them. Again, there's a practicality. A single class with 100 methods becomes very, very long. So you might break it up into different aspects of testing. You can initialize a whole the testing for everything, or you can have initialization that happens on each individual test, on each individual run of the test. There's some big design things that can be chosen. So for example, if you're doing testing on a database, you can initialize the connection to the database one time and the whole test uses the same connection. Or if you're testing a specific class, every time you put information in the class, it might impact future tests. So you create a new class every single time you run, for example. So by default, you get new stuff every time it runs. Every time a test runs, it does it on its own. So let's look at an example that you might be familiar with. So here is a functional class called time, and it has 4 methods inside of it. Advance 1 second, compare to, add, and subtract. So this is just a helper class. It just does some work. It stores time, hours, minutes, and seconds, and it does some work on that time. So for example, the test associated with this happens to have, in this case, 8 methods inside of it, but notice 4 of them are public and 4 of them are private. The private methods are internal helpers. The ones we care about are the public methods. And typically, historically in JUnit, you were required to start a JUnit test with the word test. After that, you can put whatever you want to. It just has to be unique. But historically, it starts with the word test. You will see in a second that's not absolutely required. And so in this case, I have one method that tests each one of the methods from the original class. So test tick, test advance 1 second. Tick is the idea of ticking a clock. Test compare, test compare, test add, test subtract, obviously. This tests all aspects about that. Sometimes you want to test pieces of it. Especially as a class assignment, sometimes I give you one test, which is the basics, and one test, which is the advanced, so that way I can split it up and give you partial credit for each of them. That's not typically the way real systems work, because it either works or it doesn't, but it just shows you a way you can break things up. So this basic test approach shows a simple design. Now, inside of this, the logic is entirely up to what's happening inside of each of these test cases. So obviously, if I want to test adding 2 times, I create 1 time, I create a second time, I call add, and I make sure the results comes in. We'll see that in a second. But the strategies are based off of the thing you're testing. In some cases, there might be a need to have a single test case test several methods. It might not make sense to do one. In this case, it does because each of them are entirely independent of each other. So give me another example. Here is the tip calculator. It has one method inside of it, compute tip. And its only function is to figure out that tip. But you notice here, compute tip actually has 3 parameters, the third of which is a Boolean. So in this case, I have 2 different types of tips going on. I have the basic calculator, which is the top one here, test calculator, and then I have the test roundup. And so if you look at it, the way I'm testing this is I'm calling compute tip with false on the third parameter all the time, and then I'm calling compute tip with true in the third parameter all the time. Now, this could be a case where design-wise, you could say, well, instead of having a false true, maybe what you should do is have a second method. And there's actually some legitimacy to that complaint for design, depending on the logic inside of the method. But the point of this is not the design of the calculator per se and the method, but the design of the test. I absolutely want to separate out these 2 tests because they're 2 very different concepts, and it keeps everything simple and easy. So this starts to show us a little bit of the implementation of unit testing. Unit testing, as we said, is coming up with interesting values, sending them to the code that's being tested, and then getting the results back and comparing that with something else. And so, in this example here, let me roll that back for a second. You can see the idea is if I have $20 price with a 15% tip, the $3 should be the tip that comes back. That's the answer that comes back here, 3. In this case, if I have a $100 price with a 0.1% tip, it's a penny that comes back. Or if I have a $10 price with a 100% tip, the tip is $10. And so that's what this is going on. Now, the assert equals that you see here, that's JUnit magic. We're going to come back to all those asserts in a second. But what JUnit does is say, okay, give me 2 values, 3 and something else. And it's going to return back whether that they are equal or not. They're asserting that those 2 things are equal. If they are not equal, then it shows you that message right there, sent $20, 15, and it returned false. The little trick I'll show you here, this last 0.01 is because they're floating point numbers, because I can't exactly compare 2 floating point numbers, so that's how close they have to be, within a penny of each other to be actually equal or not. So that's a little bit of some insight into a test at a very simple test level. And you can see how I can just basically do parallel little testing right here to show it even under those very different circumstances. Now, the one thing I want to pull out here is that little phrase UUT you saw in code. UUT stands for unit under test. It's a fancy word, it's a fancy way of doing it. But you got to remember when you're doing tests, there's some specific unit that you're trying to focus on. That's the idea of unit testing. And so the unit under test is the thing being tested, which is different than perhaps some helpers that are set up to do that testing. As we said, if you want to test a light bulb, I don't want to just plug it all into the flashlight. I want to have a power source that I know works, that I trust works, when I plug it in the light bulb, if the light bulb works, it will work, because I don't want to have to, debug, if you will, my entire system every single time. That's the whole point of unit testing, is I know all the rest of the stuff works, and thus, this must be the only thing that's broken. So let's deconstruct JUnit a little bit more than what we just did a second ago. So the first thing we can see is to be a JUnit test, you need to have this annotation. So at test, this is something that Java allows you to do. It adds metadata, if you will, to a function. And it's saying to JUnit, when you see this class and you see this method, run this as if it's a test. And then we talked about the assert equals, which is JUnit's way of saying, you're asserting something, that this state must be true. If that state is not true, then what JUnit does is it actually throws an exception, and it stops all further progress. So if the code doesn't know how to calculate a tip at 15%, it will not even attempt to worry about the 1% or the 100%. It just stops at that point, because an assert statement says this must be true or else it doesn't make sense to continue on. And so JUnit offers a bunch of these different types of assert statements. So you can assert something is true, which is simply saying that there's some condition that needs to be true, or something returns a Boolean that is true, or assert something's false. Assert two values are equal to each other, typically your expected value and the actual value. You can assert that something's null in the system, or certain things are not equal to. You can assert two arrays are equal to each other. You can assert something's not null. Assert two things are the same, which is not just simply equals, but they're actually the same object. I'm not talking to a person who's a clone of somebody else. I'm talking to the same person. And then assert that is a little bit more complicated version, which allows you to put multiple conditions inside of there. So I'm not going to nitpick over every single one of these methods. They're kind of intuitive once you get used to it, and there's plenty of resources online. But I want you to be aware that basically what JUnit is you define interesting inputs that somehow test your system. You define interesting outputs of what you expect back from your system. And you use these assert methods to assure that the outputs that you expect match the outputs that actually come back from your system. That's fundamentally what we've been doing in the examples you see so far. And there's tons of examples like that in all of the programs that you've been working through through the whole class. There's lots of JUnit examples. That's a really great way to test code, and that's why I have you testing your student code with those as well. So basically the process, the results of what I'm hoping you can walk away with today is you create a test class. You add test methods to test whatever you want to in that. You write test logic with the assert statements to assure that the code behaves as it should, and then you run it, and it tells you whether those things are working or not. So in theory, it's as simple as that. You just are writing logic with these asserts. The real practice is being able to think beyond just simply what somebody told me to code, and what are interesting inputs and what are the expected outputs. It requires some discipline in a very different way than writing code, because I have to think beyond and say, well, what are the crazy things that I could send to the system, and then what should the system return on this crazy thing? What are the different values? You might have to do the math by hand, or the computation by hand, or the logic by hand, and figure out what the correct answer is. But sometimes those are also given to you. And so that's what we're going to play with here. There'll be some examples to walk through, and we can definitely work through some of this. But this is the concepts that are going to be important and get you into the notions of unit testing.